Hey, physics friends. You're way over there today. What we're going to be talking about today is we are going to be doing an experiment. And we are going to have a cart on a ramp, and we're going to push it up that ramp, and we're going to find the acceleration of gravity from pushing that car up the ramp. What I'm going to do, this car up the ramp, I'm going to progressively increase the incline, so maybe 2 degrees. Find the acceleration. I'll increase it to maybe 6 degrees. Find the acceleration. I'll increase it to 8 degrees. Find the acceleration. 10 degrees, and so on. I'm going to keep stepping up the angle, finding the acceleration. So on our x, our independent variable, the variable that we are controlling, I'm going to control the angle. And what we're going to measure, the dependent variable, we're going to measure the acceleration of this. And what's going to happen is we're going to fit a line to this, and then we should be able to predict gravity because we're going to come out with an equation, and for our x value, we're going to put in 90 degrees, and it should come out to 9.8. That's our idea, our guess. So we're going to do an experiment today. What you're going to need, you are going to need a pencil and a piece of paper because I'm going to be sticking in a bunch of angles, so you're going to have to write down all those angles, and I'm going to be gleaning a bunch of accelerations from our computer software, and we're going to write those down as our x variables and our y variables. After this is all done, you're going to jump over to Google Sheets, and you're going to plot those in your x's, you're going to plot those in your y's, and we're going to make a scatter plot, and then we're going to fit a line of best fit for it, just like we did back in chapter 1 where I had you making data. Now we're going to actually take some data. My angle is going to come from this little device right here. I don't know if you can see it. If I turn it on, it tells me angle. Like if I tip this thing, it tells me what angle I'm tipping it at. So I'll just rest it here, and it's going to tell me the angle. And then my acceleration is going to come from our Sonic Rangers, our sonar devices that we're going to have. So go ahead, grab yourself a pencil and a paper, and I'll meet you on the other side. All right, friends, so here's our first incline. It's 1.2 degrees. You guys can't read it maybe you can read it from your side. And I have to make sure that I'm trying to be as parallel with the ramp as possible, because if I put it this way, it might read 0 degrees because that's not inclined right now. So I'm trying to make sure that I measure with my ramp, and it said 1.2 degrees. So that's going to be my first angle. And then let's grab ourselves an acceleration. So I'm going to hit collect. There. We've got some acceleration. So what I can do is I can grab all these points right here. Well, that didn't look, I think I got a little too close to see how it flattens up here? I think I got a little too close to the Ranger, so I'm going to do this again. And I'm not going to push it as far to see if I get better data. Oh, much better. So what I'm going to do, I'm going to grab these points right here. I'm just going to highlight them, and if I click this right here, it's going to give me the statistics. And you'll see right here it says the average, negative 0.194. We're just going to go with 3 decimal places, 0.194. So again, if you've got your piece of paper, here's what we're going to write down. 1.2 degrees and negative 0.194. Those are my 2 data points that I've written down so far, and let's go to our next one. So maybe you can tell, maybe you can't tell, but I stuck another 2x4. I've got a bunch of 2x4 blocks that I'm going to stick underneath this ramp, and I'm at 3.2 degrees. So that's our next x, 3.2 degrees. And now I'm going to find my acceleration. Nice. Got some good data. So I'm going to highlight this section right here. And I'm going to find the average again. So my average is negative 0.535. Negative 0.535. Let's boost it up one more time and try her again. Here we are. I've got 2x4s under there, and I keep going up at my ramp. I'm at 5.2 degrees this time, 5.2 degrees. and let's get ourselves some data. Nice. It's kind of fun to just watch too, by the way. Oh shoot, I lost it. I think if I hit Control Z, I can go, yeah, there it is. So I'm gonna grab this section right here, and this is cool. You can actually see that its acceleration is the same. All these down here, regardless. So let's get an average here. My average is negative 0.858. 0.858. All right, let's grab our next one. Here we are at our next incline, and I'm measuring that to be 7.1 degrees. I don't know, maybe you guys can see it from where you're at. Probably not, is my guess. I have to like tilt it 7.1 degrees. And let's find ourselves some acceleration. I'm going to try it one more time. All right, so I'm going to grab the acceleration here. And you can see that the acceleration is going up. Like I know that I'm past 1 right here at this point. Find my average. My average is negative 1.189. Negative 1.189 here. We'll go to our next one. Well, I can barely see you guys from over here. My angle, 9.2 degrees. So I've got 9.2 degrees. Oh, sorry, 9.1 degrees. 9.1 degrees. And let's find us an acceleration. So, right here, we're going to find our average. So my average for this one is negative 1.515. Negative 1.515. So you can see from where you're at, maybe I'm kind of writing down my numbers. That's what you should be doing too. You just be writing them down on a piece of paper so you can put them into Google Sheets in just a moment. And here we are at our very last one. I've got 1, 2, 3, 4, 5 2x4s underneath there, and I'm measuring 11.1 degrees of incline. So it's 11.1 degrees. And let's find us an acceleration. I'm going to try that again. Nice. So, grab my stuff here, find myself an average. This last one, the average is negative 1.860. Negative 1.860. So I can step my way back if I just hit Control Z, just so you can see. You can see all sorts of stuff as I step back through all of my graphs that I did. Well, maybe I can't. Well, that's all right. Let's go over to Google Sheets. Follow me. All right, so here I am at Google Docs, and you'll find this. I've attached this Google Doc to this assignment that you can fill in with your stuff. So the first thing that you're going to do is you're going to put in your angle, and you always got to make sure you put in your units. So we're measuring angle, which is degrees, and acceleration, which is in meters per second squared. And that little caret thing is like shift number 6 to represent like an exponent. So make sure that you put your units in there. I'm going to put in all of my angles that we did, 1.2, 3.2, 5.2, 7.1, 9.1. Those are all the angles that I measured. And then we're going to enter in all of the angles that we had. So negative, 0. All these, there they are. So I'm going to let you pause it right here. If you didn't get those written down, you can pause this and then put your numbers in right now and then come back to me. All right, next thing I'm going to do, I am going to make sure that I can see all this stuff. So I mean, size 10 font. It's a little bit too small. So I just want to make sure that I can see everything. I'm going to increase this. I like my data, the numbers to be centered. So we're going to put the alignment here centered. And this 1.86, it's missing at 0. So remember how to add at 0 there. So everything has the right number of significant figures. Boop, there you go. We're going to put a line underneath this. So over here, we'll make a bottom line. And then right here, we're going to make a middle line, a right border. So now my data is in a nice, what we call a T table right here. Now I'm going to have you do something kind of weird. I don't, believe it or not, this isn't going to work if I use the angle in degrees. What I'm going to have to do is use the sine of the angle. The sine of the angle. And so bear with me. And this is the one piece that kind of, I didn't want to do this lab with you because I don't know if you know what sine or cosine means yet. You will. We're going to use it pretty extensively, not next chapter, but the chapter after. And then in pre-calc's going to basically dwell on it for the rest of the time. So I'm like, I kind of debated whether or not to do it, but I am going to do it. So here are the sines of all those angles. So this one's 0.021, the sine of 1.2 degrees, 0.056, 0.091. And the sine of 7.1 is 0.124. The sine of 9.1 is 0.158. And the sine of 11.1 is 0.193. So these are the actual numbers that we're going to graph as our x values, our independent variables, the things that we as the experimenter are controlling. So I'm just going to increase that font, put her in the center. I'm going to write angle sine. I'm going to say the sine of angle. Sine of angle. And I'll also make that 14. Increase my spacing here. Oh boy. Because I put that in the first one. That's why I did that. Put an underline there. Now I can graph these. Put one more line right here. I want to graph these as my x values and these as my y values. So what I'm going to do is I'm going to highlight these, hit the control, hold down the control key, and grab these so I can grab both of those. And I'm going to go insert chart. And we want to make sure that it's an x, y scatter chart. And I think that that's what it defaulted to. And look at that. That is some really nice stuff here. We're going to use, get you guys out of the way. We're going to put a line of best fit to this. Oh, first of all, I'm going to title. Got to do all sorts of stuff. Oh man, horizontal axis. Should have a title for this thing. Is it? So we're going to add a trend line. I noticed that my titles were already here as I got looking at this a little more. It's already got my sine of my angle labeled and my acceleration in meters per second squared. And we got a pretty nice little, looks pretty linear to me. So we're going to grab a, let's see here, series. And we drop down to a trend line. And we're going to show the r squared. And then we're going to also use the equation. And just so we can tell what's going on. Oh my gosh, r squared equals 1. Holy cow. That means we are baller. This data is modeled so perfectly by this this right here. Oh, I can't believe that it's 1. That's incredible. Nice work, you guys. And then we can find the shoot, what did I do here? Now we can figure out what we came here to find. Like, what happens if we put 90 in here, right? Remember, 90 degrees. You probably don't know this, but the sine of 90 is 1. So if we put 1 into our equation right now, I'm going to grab my calculator here. So negative 9.68 times 1, this is 1, plus 0.0117. And we were expecting something around 9.8, and we got 9.67, right? So the acceleration that we're thinking that we're getting here is 9.67. If what we call extrapolation, we're extrapolating this out until we get to the number 1. So what would the acceleration be at the sine of 90? And the sine of 90 is when my graph is perfectly like this. And so here's where I'm going to leave this to you guys. I've got some questions down here at the end that I want you guys to answer. Question 1. So these are the questions that I want you guys to answer in your sheet. How could we make this experiment more accurate? What are some of the sources of error that you maybe saw that I was doing that we could make this a little bit more accurate? Did we find what we were expecting? Well, why did we do this experiment in the first place? And did we find it? Do you think our experimental value of acceleration, why do you think our experimental value of acceleration due to gravity was a little bit low? Do you have any ideas why that would be? And then lastly, what was the equation for the line of best fit? And I don't want you to use x and y because this turns out to be x and y, and we know that we can screw that up when we start putting things in there. I want you to use a for acceleration, and I want you to use the letter O. I have used theta because typically we use Greek letters for, but I didn't know if a lot of you knew how to find theta and type it in. Bonus points if you can put theta in your answer, but just use the capital O for your angle. Again, when you're finished, I want everything to look like this. I'm going to delete this guy. I'm going to delete these guys. And I'm going to get rid of this right here. No. And I want yours to end up looking like mine. So good luck, kids. Have some fun, and we'll talk to you later.